So in this session we're going to do redox. It's a chemistry topic which needs a deeper understanding, though it's very simple but a bit challenging if you don't grasp the concept to the depth of it. So in this session we'll cover reduction, oxidation, and balancing of redox reactions. But before we can delve any further, let's try to understand what redox reactions are. So let's break down this term. For better understanding, we need to break down the term redox. So redox is a word made up of two prefixes rather. Prefixes, I simply mean the first letters of a certain word. So they just combine RE from RED from reduction, so this is reduction, then OX from oxidation. So you can't understand redox reaction minus having an understanding about reduction and oxidation reactions. So let's combine these two terms to help us now understand redox. So when you're talking about redox, you're simply referring to a reaction in which a reduction and oxidation are taking place simultaneously or at the same time. That is the meaning of redox. Just a reaction in which oxidation and reduction are taking place at the same time. So let's understand oxidation. What is oxidation? So I'll get rid of this. So let's start with oxidation. So oxidation can be defined in three many ways. Yeah. Oxidation, one of the definition which you can give, oxidation is simply the gain of oxygen. Gain of oxygen. That is oxidation. Can give an example of, let's say, magnesium plus oxygen giving magnesium oxide. We balance it by putting 2 on the magnesium oxide, so that is simply oxidation. Let's look at another definition for oxidation. How can you define oxidation? So the other definition is simply the gain. So the gain or increase in oxidation state. Okay, that is simply oxidation. So increase in oxidation state, increase in oxidation state. So an example I can give here, let's say you have iron, which is just an iron atom forming, or let's say iron 2, iron, which is an anion forming iron 3. Then to balance this, you add an electron there. So you can see that the oxidation state of iron 2 is 2 there, but it has increased to 3 plus. So this is oxidation. The other definition for oxidation, you can say oxidation is simply the loss of hydrogen. So we can have, we are saying loss of hydrogen Okay, on this one, which example can I give? Let's say methane. Methane, that is CH4. Then it loses this hydrogen. The hydrogen which it has to remain as carbon plus hydrogen. So to balance this, we put a 2 there. Yeah, when methane loses this hydrogen, this is simply oxidation. Then the other definition you can give for oxidation, you can say oxidation, okay, this would be our fourth definition. Oxidation is simply the loss of electrons. So we can have, let's say, magnesium. Then this magnesium is forming magnesium ion. We know the charge must be 2. Then it loses 2 electrons. That is oxidation. So to remember this, you can use a memory aid which is known as oil. So with oxidation, it is loss in electrons. No wonder we are saying oil. So oxidation is loss of electrons. That's what that's mnemonic mean. Then, upon appreciating the concept of oxidation, now let's look at reduction. Reduction, when something is undergoing reduction or it is being reduced, what does it mean? So the first definition we'll give there, reduction is simply the loss of oxygen. An example I can give, let's say you have copper oxide, copper to oxide, plus hydrogen. Then this copper to oxide loses the oxygen there to remain as copper plus, of course, water will be formed. So this is simply reduction. Why? Because there is a loss of oxygen from copper to oxide to copper atom. Then the other definition you can give for reduction, reduction is simply the gain. For oxidation, we said it is increase in oxidation state, but for reduction is simply the reduction in oxidation state or the decrease in oxidation state. So we can get, let's say we have, which one can I give? Okay, let's say we have a bromine atom. Then this bromine atom is being reduced to bromide ion. So to balance this, we just add 2 on bromide ion. That is reduction. Why? Because the oxidation state of bromine, here it's 0, but it has been decreased to -1. So here it is 0, there on the product is 1. So this is reduction. The other definition in which you can define reduction, you can say reduction is simply the addition of hydrogen. So you can have, so let me just write this, addition of hydrogen. So when you add hydrogen to a certain compound or to a certain element, you are simply reducing it. So I can give an example of, let's say, carbon plus hydrogen giving methane. Methane, it is CH4. So this is simply reduction. Why? Because there's addition of hydrogen to carbon in order to make it methane. So to remember this, we can use, to remember the definition, any definition, maybe one of the definition of reduction, we can use what is known as a rig. A rig. Rig reduction is simply the gain in the gain in hydrogen Reduction is also defined as the loss of oxygen. Okay, so you can use RIG in order for you to remember that reduction is the gain in electrons and the gain of hydrogen. So you can use RIG. R reduction is then gain to symbolize gain in hydrogen and gain in in the in the electrons. So that is it. You need to know about reduction and oxidation. So the other thing you must understand here is what is a reducing agent. Reducing, or let's start with oxidizing reagent. Oxidizing reagent. So for this, when you're talking about oxidizing reagent, this is simply a reagent or a substance that facilitates oxidation. So how can you know that this is an oxidizing reagent? An oxidizing reagent is simply reduced in a chemical reaction. Okay, it is reduced in a chemical reaction. So an example I can give is dichromate. Dichromate is simply Cr2 or 7 with a charge of -2. Dichromate is an oxidizing reagent. It undergoes reduction and it facilitates oxidation. So it's just the opposite. When you're taught to define an oxidizing reagent, you say it's a reagent which facilitates oxidation but itself undergoes reduction in a chemical reaction. So let's understand now what reducing reagents are. Reducing reagents. So for reducing reagent, that's just the opposite of oxidizing reagent. For reducing reagents, these are substances that facilitates reduction, but themselves undergoes oxidation. So those are reducing agents. They facilitate reduction, but themselves undergoes reduction. So what can I give as an example? We can have permanganate. For this one, we can have permanganate ion. Okay, the charge must, must be just negative there. Okay, permanganate ion is a reducing agent. It's a reducing agent. So this permanganate ion, when it is facilitating what is known as reduction, itself it undergoes oxidation. So that is very important for you to understand. So basically this is what you need to know about reduction, oxidation, and also reducing agent, oxidizing agent. Now let me give an example of a redox reaction. We said a redox reaction is a reaction in which both oxidation and reduction are taking place at the same time or simultaneously. So I can give an example of, let's say you have copper 2 plus then plus zinc there, giving zinc 2 plus then plus Cu. In this reaction we can see that for copper there is a decrease in the oxidation state. The oxidation state for copper there on the reactant side is 2, but on the product side is just 0. So the decrease in oxidation state, that is oxidation. That is reduction. That is reduction. So we can say copper is undergoing reduction. Then for zinc, we can say that zinc is increasing in oxidation state. There it was 0, but it has 2 plus there. So for redox reaction, always you write with a sign in front. So if you have maybe the answer is 2, the oxidation state, you can't say it's 2, you say plus 2 to symbolize that we are talking about oxidation or redox reactions. So that is very important, because when you just write 2, 2 is just a general number. So you need to specify, are you talking about reactions or oxidation reactions? So for oxidation, always write together with a sign in front to show the oxidation state. So we can see that in this reaction, zinc is increasing in its oxidation state. Initially it was zinc with an oxidation state of 0, but it has increased to 2 plus. So because it has increased to 2 plus, we can say zinc is undergoing what is known as oxidation, because we defined oxidation as simply the increase in the oxidation state. Okay, so basically that is what you need to understand. The other thing you need to understand in this topic is how to calculate the oxidation state of a certain element in a compound. Let's say you have copper copper to oxide. How can you calculate the oxidation state for copper? So one thing you need to understand here is that for neutral compounds, for neutral compound or uncharged compound, when you're talking about neutral compound, these are just compound we do not have any charge on them. So for neutral compound, for you to calculate the oxidation state, you need to know that the sum of all the oxidation states of the respective elements in that compound is equal to 0. So for example, you need to calculate, let's say, the oxidation state for copper and copper 2 oxide. You simply say oxidation state of copper in copper 2 oxide plus oxidation state of oxygen in copper 2 oxide is equal to the charge there. It is just neutral, so is equal to 0. So how can you now calculate the oxidation state for copper? So this is how you can do it. So one thing you need to understand here is that the oxidation state for oxygen is just -2. So I can give you some oxidation states. Like for copper, you need to know just +2. For group 1 elements, their oxidation state is +1. For, let's say, group 7 elements, which are known as halogens, their oxidation state should be -1. And for group 2 elements, which are known as alkaline earth metals, those have oxidation state of +2. So we know that oxidation state for oxygen is just -2. So we're going to say oxidation state of copper plus oxidation state of oxygen. But when we wrote oxygen like that, oxygen, there is just one atom of oxygen, so it will be plus -2, then is equal to 0. So let's now find the oxidation state for copper in copper 2 oxide. So what will be the value there? So I'm going to say oxidation state of copper will be equal to positive times negative, that is just negative. So this 2 will go to the other side of the equation. In short, to find the additive inverse of -2, which is +2. So you're going to say 0 plus 2, and that will give you 2. We have found the oxidation state of copper to be equal to 2. But you can't just say 2. I initially mentioned that when writing the oxidation state, you need to include the sign, so it will be +2. That's how you can get the 4 marks. Then the next thing, the last thing we shall mention here, is just how to balance redox reactions. Balancing of redox reactions. It is very simple but challenging, because this is very confusing most of the times. Like, how do you balance redox reaction in acidic medium, in basic medium, or in basic solutions rather? So this is how you go about them. So I can give an example. Let's we'll start with balancing redox reaction in acidic. When you know balancing redox reaction in acidic, you'll simply be able to balance redox reaction in basic, because For you to balance a redox reaction in basic, you need first to understand how to balance in acidic. That's when you add just a hydroxide ion, then you get the balanced equation for basic solution. So let's have a certain reaction. Let's say you have dichromate, which is C2. I mentioned about dichromate C2, let's say O7, then with a charge of -2 there, plus 2 iodide. Iodide ion is the iodine which is charged, okay? Then plus chromium ion. So plus chromium ion, which is C2, C3 plus with a 2 there, balanced, then plus iodine. Okay, so how can you balance this redox reaction? Mind you, we are talking about in acidic. So we are balancing in acidic solution. In acidic solution, meaning that in a solution which has the highest number of hydrogen ion as compared to hydroxide ion. In short, in a solution which contains an acid. That is the basic understanding there. So how can you balance this kind of a reaction? So this is how to go about it. So the first thing you need to do here is to split this reaction into half equations. So to write half equations, you need to write one reaction for oxidation and the other one for reduction. So I'll write a half equation for oxidation here. We can see that dichromate is undergoing reduction because there's a loss of oxygen. Iodide is undergoing oxidation because there's increase in the oxidation state. So let's split this into two half equations. So we're going to have Cr2O7 with a 2 minus there, undergoing what is known as reduction to produce 2Cr3 plus. Okay, so we have that. The next thing we need to do here is to write the half equation for an oxidation reaction. So we have iodide there with a 2 minus undergoing what is known as oxidation to produce an iodine ion. Okay, let me wrap the top part there. Okay, so here is the trick part which you just need to understand. Alright, so we have these two reactions. There is one for oxidation and the other one for reduction. How do you balance these redox reactions? So the first thing you need to understand here is that one, for you to balance oxygen, okay, whenever you're balancing oxygen in a redox reaction, you add water to the other side of the equation, okay. Then for you to balance hydrogen in a redox reaction, you add hydrogen ion. So basically that, if you're able to do that, then you're home and dry. So let's do the first one. Let's balance the first one. So the first one, you have dichromate changing into a chromium ion. That is reduction. So we have oxygen there. So what are we going to do to the right hand side? We simply add water. So there are 7 oxygen atoms there. So we're going to say plus 7 water molecules. Basically that. Then the next thing we need to do here, we can see that when we added 7 molecules of water on the product side, the number of hydrogen atoms has increased there. So we have 7 times 2, we have 14. Now we have 14 hydrogen, and I said for you to balance hydrogen in a redox reaction, we simply add hydrogen ion. So we are going to add 14 because 7 times 2, that is 14. So we add 14. So we're going to say plus 14 H plus, which is hydrogen ion. So we're going to say plus 14 H plus there. Okay, 14 H plus. So we have now this reaction. So what is the next thing we're going to do? The next thing we're going to do here is that we're going to balance now the charge. We're going to balance the charge. We can see that here the charge is 14 plus, so we have 14 plus or plus 14, then this is negative 2, so minus 2. The charge here we have plus 12. So what about this side? Here the charge we have, it is you multiply the stoichiometric coefficient multiplied by the charge, that is 2 times 3 plus, that is 6, or plus 6. So now how do you balance the charge? So to balance the charge, you simply do this. You're going to subtract electrons. So we're going to subtract electrons. So you simply add electrons to the side which has a greater charge. That is just the trick part here. You might be confused, like, is it to add electrons to the side which has a less charge or to the side which has a greater charge? You see, electrons are negatively charged. So when you are adding, you are simply subtracting. That's the meaning. So you add 6 electrons here to the charge which has plus 12, so that you get 6, which is plus 6. So in this case, we'll be able to balance now this reaction. Okay, so what we have done here is that we just add 6 electrons. So let me write it here. So I'll say plus 6 electrons here. Let me do this. I get rid of this other equation, then we'll do it individually. Okay, so what I mean is that you add 6 electrons here. Once you have added 6 electrons there, then the reaction will be, let's now write the balance now. I mean the balanced reaction for this reduction reaction. So we're going to get plus 6 electrons, then plus 14 hydrogen ions, then plus dichromate ion, that is the charge. Then on the product side we have 2 chromium ion plus 7 water molecules. Okay, so that is the reaction we have. Then let's balance the second reaction, which had oxidation. So the second reaction which we had was iodide. Okay, let me write it here. So it was iodide with a 2, as this one was already balanced. We just need to balance the charge. So 2, it was 2 minus, then giving iodine atom rather. Okay, so this is what we had. So we need just to balance the charge. Here the charge is minus 2, here the charge is plus 2. So where are we going to add the electrons? I said you simply add the electrons to the side which has a greater magnitude of charge. Excuse me. So here you add the 2 electrons to this side which has plus 2. So you add 2 electrons. So you're simply going to say plus 2 electrons. Now this is very simple to finish up. So what you're just going to do is that you balance now the electrons. So how do you balance the electrons? So here is the trick part. To balance the electrons, you simply interchange the magnitude of charge of that same electrons you added. In short, what you need to do here is that these two you swap. You multiply the first reaction by 2, then the second reaction you multiply it by 6, because there are 6 electrons there. So you'll be able to balance now the numbers of electrons. So you just interchange, you multiply the first reaction by the number of electrons there in order to balance it. Okay, the way we deal with simultaneous equations when you're dealing with elimination, you need to balance the first and the second reaction, so you swap. Okay, so let's now multiply this one. So here the first reaction, the second reaction multiplied by 6, then the first reaction will multiply by everything. We need to multiply it by 2. So this reaction entirely will be multiplied by 2. Okay, so once we have this, you discover that the numbers of electrons now on the first reaction will be 12. Even in the second reaction, there will be 12. So this can cancel now with this. The electrons now can cancel. So what you are simply going to remain with will be 14. 14, we have 14 hydrogen ion there. Okay, so this is what we're going to remain with. Let me use a different ink. Okay, so let me use this ink. Okay, so what I'll have here is that what we've done, we've balanced the charges. Okay, we've balanced the charges by just multiplying by 2 there and the bottom by 6. So what we are going to have will be 2 multiplied by 14 hydrogen ion. We are going to have, that will give 28 hydrogen ion, then plus, and remember we are adding now what is on the reactant, everything on the reactant side plus everything on the product side. So we're going to have plus 2 multiplied by dichromate. We're going to have 2 Cr2 or 7, 2 minus. Then we come to the bottom. What do we have? To the bottom we are going to have 6 multiplied by 2 iodide, so we're going to have plus 6 iodide, like that. Then let's now go to the product side. The product side, we have 2 multiplied by 2 chromium, so we're going to have 4 chromium ion, like that. Then plus 2 multiplied by 7 water molecules, so we're going to have plus 14 water molecules. Then plus 2 multiplied by 6 iodine ion, we're going to have 6 iodine ion, like that. So 2 there should be 2. Okay, like that. So at this point we have basically balanced this redox reaction. Okay, we have balanced this redox reaction. Actually, when we multiplied 2 iodide ion by 6, there we are supposed to have 12. Okay, let me just rub this. We're supposed to have 12 iodide. Okay, so what can we do now here? So what we can do now is just to simplify. Okay, you simplify everything. So to simplify, we know that there's a common factor or the common number which can go in these all these numbers. So you can just say 2 can go into 28, it can go into 12, it can go into 14, it can go into 12, again this one, it can go into 4, it can go into 6. So you just multiply this reaction by half. So what are you going to have? So basically what you're going to have is that half multiplied by 28, that will give you 14 hydrogen, plus half multiplied by dichromate, we're going to have dichromates, just dichromate without any stoichiometric coefficient. Then half multiplied by 12 iodide, you're simply going to have 6 iodide. That is iodide. Iodide is a charged iodine, so you're going to have that. Then half multiplied by 4 chromium ion, you're going to have 2 chromium ion. Then half multiplied by 14 water molecules, you're going to have 7 water molecules. Then half multiplied by 6, let me do this, half multiplied by 6 iodine, you're going to have 6 iodine. Half multiplied by 6 iodine, you're going to have 3 iodine. So 3 iodine there. Okay, iodine, that is capital letter I with a subscript of 2. Okay, so we've now basically balanced. We've balanced this redox reaction. So we've balanced the redox reaction. Okay. So this will be our balanced redox reaction. So there we had the plus 6 plus 3 and then. So this will be our balanced redox reaction. Okay. This is how to balance this redox reaction in basic solution. Alright, so let's now do a different question for us. For this was in basic, this was in acidic, this was acidic. Let's do a question on basic. So I'll clear this. So for basic reactions, you need first to balance it in acidic medium, then you'll be able to balance it in basic medium. Okay, so let's have a question. Let me use CO2. So this is the question. We have CO2 H2, CO2 H2, then plus manganese ion MnO4, giving CO2 plus Mn, manganese ion. Okay, so we have this question. So the first thing, you write it in half equations. So we have manganese, or rather let's start with this same one, CO2 H2 is producing CO2, which is carbon dioxide. Then the half equation for the second one, we have manganese, which is MO4. Then it is producing manganese ion. Okay, like that. So let's balance first the first one. The first one, we have oxygen there, it is 2, carbon is balanced, hydrogen. So to balance hydrogen, we need to add, we add just 2 hydrogen here, 2 hydrogen ions. Okay, then the charge, we've noticed that the charge here, it is 0 on the reactant side, on the product side it is +2. So to balance, you simply add 2 electrons there, you would have balanced the charge. Then to balance the oxygen on this other reaction, we need just to add, since we are balancing oxygen, we add water this side. So there are 4 oxygen atoms, so we are going to add 4 water molecules this side. Then if we notice that the charge here, it is +2. So what are we going to do to the charge? We're simply going to add, okay, we're simply going to add the electrons. So we're going to add now 2 electrons, but you see here the hydrogen atoms have increased. There are now 8 hydrogens here on the product side, so we need to balance also the hydrogen on the reactant side. So by adding just 8 hydrogen ions, okay, so we are going to add +8 hydrogen ion this side, okay, and would have balanced the hydrogen because there will be 8. Now let's balance the charge. We can see that the charge here, it is now +8. Here it is +8. Then here the charge is, if you notice the charge here, it is +2. Okay, so the charge is +8, they are +2. So how are we going to balance the charge? We simply add 6 electrons to the side, which has a greater magnitude, so +6 electrons there. Okay, once we add 6 electrons now, we'll be able to balance this reaction. Okay, so this is what we have. So we are now going to balance the electrons. How do you balance the electrons? You can simply interchange. There we have 2 electrons, so you can multiply by 6 so that you get 6 electrons. Even there you can multiply by 2 so that you have 12 electrons, and the 12 electrons can cancel. But you can use the shortest way to do this. You can just multiply this equation, the entire equation, by 3. There's no need to multiply this other equation, because once you multiply, or you multiply the second equation by 1, but 1 by this equation is just the same equation, so there's no need to multiply this. Okay, so you'll be able to find this. Let me clear the top part. So for the second reaction, this is what you're going to have: 3 times CO3, so you're going to have 3 CO2, then H2, okay, then giving 3 carbon dioxide there, plus this one will be 3 times 6 hydrogen, that is 6, 2 hydrogen, rather 3 plus 2 hydrogen, that is 6 hydrogen, then plus 6 electrons. So I get rid of this middle part. So now we can see that the electrons are now balanced. So we can cancel out, and they are on the opposite side, so they can cancel out. These electrons can simply cancel out. So what we have now as a balanced reaction. So let me change the ink. Maybe let me use this one. Let me use red. Okay. Alright, so what we are going to have now is 3CO2, then H2. We are adding these two reactions, then plus, okay, so plus, here we have 8 hydrogen ion, but you see here we have 8 hydrogen ion, there we have 6 hydrogen ion, and they are on the opposite side, so we can simply cancel out those 6 hydrogen ion, because and there we remain with 8 with 2 hydrogen ion, because 8 hydrogen ion minus 6 hydrogen ion, you get 2 hydrogen ion. So here we have 2 hydrogen ion, then plus manganate MnO4, then giving what? Giving manganese ion rather, plus there we have 3 carbon molecules, carbon dioxide molecules there, then plus what do we have? We have 4 water molecules there. We have 4 water molecules, so H2O. Okay, let me write it this way. So H2O, that is water molecule H2O. Okay, now let me get rid of this. So now, how can you finish up this reaction? Okay, so we have 2 hydrogen ions on the reactant side. The only thing we need to do here is to add hydroxide ions. Okay, we add hydroxide ions on the both side of the reaction, okay, because we are balancing this, mind you, we are balancing it in basic solution. So in basic solution, when you're talking about something basic, it contains hydroxide ion. So simply you add how many hydroxide ion will be able to neutralize these 2 hydrogen ions. So there will be 2 hydroxide ion. So you add 2 hydroxide ion. What you do on the left hand side, you also do the same on the right hand side. So even here you have that. So which reaction are you going to have now when these 2 hydroxide ion neutralizes this hydrogen ion? They'll be able to form 2 water molecules. Okay, because in a neutralization reaction, we say when a hydrogen ion reacts with a hydroxide ion, they'll be able to produce water. Okay, so we'll have 2 water molecules here once this undergoes neutralization. But you see, on the reactant, on the product side, we have 4 water molecules. So these water molecules will cancel, will simply subtract, in short. So we're going to remain with 2 water molecules there. Okay, and what we are going to have as the final result of the reaction is 3CO2 CO2 H2 plus 2 H plus MnO4, then giving, okay, so it is giving 2 plus Mn. It should be manganese. This was manganese, not magnesium. So it should be N there. Okay. So there it should be N. Even there it should be N. So Mn 2 plus, then plus 3CO2. The water molecules which have remained there, there are 2 water molecules. Then plus the hydroxide ion, there are 2 hydroxide ion. So this is how you balance up this reaction in a basic, medium or basic solution. So we've done the full topic, redox reaction. Basically this is what you need to know. Maybe in the next part we'll just do exam questions, then just to cement the concept. So this is it about redox reaction. Thank you for watching. Have a great day.